Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. The computer is the greatest invention of the 20th century. Parallel processing is the biggest advance in the history of the computer. The history of civilization is the history of technology. Fire is man's first invention, or rather, man's first discovery. Who domesticated the first chicken? Who domesticated the first goat? Who rode the first horse? The names of ancient scientific pioneers are lost in the midst of time. Who solved the first quadratic equation? Who programmed the first ensemble of processors that led to the discovery of the modern supercomputer that computes in parallel? Parallel processing, the technology that makes the new computer faster and makes the new supercomputer fastest, is the most important invention in the history of the computer. The experimental invention of the massively parallel processing supercomputer that solves many problems at once instead of solving only one problem at a time, and its absorption into new computers and into new supercomputers is one of computing industry's most hopeful narrative. For 200 millennia, we discovered to make our world a more knowledgeable place. We discovered to discover new fields of study. The new field of study that I discovered in the 1970s and 80s is called massively parallel processing supercomputing. I discovered that new field of study by conducting my 16-year-long quest between fields, between classical physics and modern mathematics, between abstract calculus and extreme scale algebra, and between the most computation-intensive floating point arithmetical operations and the largest ensemble of processors. The supercomputer is a witness to humanity's most computation-intensive problems. The supercomputer doesn't just solve the toughest problems in extreme scale computational physics. The supercomputer is the modern divining rod for discovering more crude oil and natural gas. The supercomputer is the crystal ball for foreseeing otherwise unforeseeable global warming. The supercomputer is an instrument for telling the future. I discovered that the global circulation model that is executed across a new internet, that's a new global network of commodity processors or a new global network of as many computers, and that emulates a new supercomputer, can be used to gaze across the centuries. The invention of how to compute in parallel was a revelation that changed our knowledge of how to compute things that were previously impossible to compute. In the 1980s and earlier, the big overarching question in supercomputing was, can an ensemble of all the slowest processors in the world outperform the fastest supercomputer and change the way we look at the modern computer? For the 15 years onward of June 20, 1974, that parallel processing grand challenge question kept me up at night. In the final days leading to my experimental discovery of massively parallel processing supercomputer, a discovery that occurred on the 4th of July 1989, I had my heart in my throat. I had the visceral feeling that my massively parallel processing supercomputer results will be historic. That invention of the massively parallel processing supercomputer is the reason 12-year-olds are writing school reports titled "The Contributions of Philip Emeagwali to the Development of the Computer." On that 4th of July 1989, the first direct measurement of the fastest computation ever recorded across an ensemble of processors was recorded. On that 4th of July 1989, I experimentally discovered that massively parallel processing supercomputers can be used to solve computation-intensive problems that neither sequential processing supercomputers nor vector processing supercomputers can solve. My invention was about making grand challenge initial boundary value problems of extreme scale computational physics that are impossible to solve possible to solve. I figured out how to massively parallel process the most computation-intensive problems arising in physics and how to massively parallel process them so that a time to solution of 30,000 years can be reduced to a time to solution of just 1 day. My contribution to physics is this. Before I figured out how to harness the power of the massively parallel processing supercomputer that occurred on the 4th of July 1989, the most extreme scale computational physics codes were only executed on only one supercomputer. After my invention, the most extreme scaled computational physics codes were only executed across millions upon millions of commodity off-the-shelf processors. In summary, we knew the land before parallel processing, and we named that land sequential processing, or the land where we computed only one thing at a time. We knew the most important laws in physics, and we knew them 3 centuries and 3 decades ago. We knew how to encode those laws of physics as the most advanced expressions in calculus called partial differential equations. And we knew them nearly a century and a half ago. We knew how to discretize those partial differential equations to their algebraic approximations, and we knew them almost a century ago. We knew how to further reduce the systems of equations of algebra and how to reduce them to an equivalent set of floating point arithmetical operations. And we knew them over half a century ago. We had been executing those floating point arithmetical operations since 1946, the year the first digital programmable supercomputer was invented. We knew the land before parallel processing as the land where we computed one thing at a time. In the 1980s, we did not know the land after sequential processing or computing many things at once. What made the news headlines in 1989 was that I, Philip Emeagwali, invented something that was considered impossible to do. Namely, I crossed from the land of sequential processing to the land of parallel processing. What made the news headlines was that I figured out how to solve the most computation-intensive problems arising in extreme-scale computational physics. Solving the grand challenge problem of computational physics sharpened and deepened our understanding of both the computer and the supercomputer, and changed the way we look at both technologies. I arrived at that unknown world by forging a path never taken before. I arrived from a narrow footpath that was never taken before. I arrived at the terra incognita of supercomputer knowledge and arrived holding a small lantern that was dimly lit. The modern supercomputer that computes faster by massively parallel processing across billions upon millions of processors is the fastest computer in the world. The massively parallel processing supercomputer became the world's fastest computer by computing many things at once, instead of computing only one thing at a time. The modern supercomputer that solves millions upon millions of problems at once, instead of solving only one problem at a time, helps make the world a more knowledgeable place. The modern supercomputer that reduces time to solution from 30,000 years to just one day increased our understanding of our universe. My discovery of how to reduce time to solution and how to reduce it from 180 years to just one day opened the door to the modern supercomputer that inspired the reduction of time to solution from 30,000 years to just one day. Please allow me to introduce myself. I'm Philip Emeagwali. The inventor is a prisoner of his invention and somewhat need an outsider to fully explain his invention to him. Yet, allow me to introduce myself. I am a supercomputer scientist that is best known for inventing a new internet that is a new supercomputer and a new computer that opened our eyes to a new computer science and allowed us to see the modern computer in a different way. A story in the June 14, 1976 issue of the Computer World magazine was titled, quote, "Research in Parallel Processing Questioned as Waste of Time," unquote. 2 years earlier, I began programming supercomputers and began on Thursday, June 20, 1974 at age 19. I began supercomputing with one of the world's fastest supercomputers that was in Corvallis, Oregon, United States. That supercomputer was the first to be rated at 1 million instructions per second. As a 19-year-old supercomputer programmer, I felt like a small boy that was in charge of a big ocean liner that turned slowly. 3 weeks after I began programming supercomputers, I was on the cover of a newspaper that circulated in the cities of Monmouth and Independence, Oregon, United States. I became a local celebrity. Over the years, I realized that in Africa, a breakthrough technology is a sacred object. The African that invents a groundbreaking technology can occupy the position between Albert Einstein and Nelson Mandela and occupy that position in the minds of Africans at home and in the diaspora. That African inventor is invited to sit on the African high table. The invention of the fastest supercomputer is a concrete and visible achievement that everybody understands as pushing the frontier of technology, as well as the boundary of human knowledge. None of the 25,000 vector processing supercomputer programmers of the 1980s showed the massively parallel processing supercomputer some love. In the 1970s and 80s, the terra incognita that was the emerging field of massively parallel processing supercomputing was as empty as a ghost town that had only one permanent resident. I, Philip Emeagwali, was that permanent resident of the farthest frontier of supercomputing called massively parallel processing. In the 1980s, I discovered the massively parallel processing supercomputer to be like a book that sat on the library shelf for 108 years and sat without once being checked out. I was the only full-time programmer of the most massively parallel processing supercomputer of the 1980s. I visualized that massively parallel processing supercomputer as a small copy of the internet. The reason my experimental discovery made the news headlines was that for the 4 decades onward of 1946, the parallel processing machine was a supercomputer hopeful that no supercomputer scientist understood what made it super. The new supercomputer that I invented on the 4th of July 1989 in turn gave birth to a new field of computer science. A new supercomputer gives birth to a new computer science. The May 8, 1987 issue of the Chronicle of Higher Education carried an article that was titled, quote, "Some hail computational science as biggest advance since Newton Galileo," unquote. Fast forward 3 years, the June 27, 1990 issue of the Chronicle of Higher Education carried an article that proclaimed that I, Philip Emeagwali, had made the biggest advance in computational science. Back in 1989, one of the science news headlines was that an African supercomputer wizard in the United States had experimentally discovered how and why parallel processing makes modern computers faster and makes the new supercomputer the fastest, and invented how and why to use that new supercomputer knowledge to build a new supercomputer that encircled the globe in the way the internet does. I am that African supercomputer scientist that was in the news back in 1989. I was in the news for inventing the massively parallel processing supercomputer. I was in the news for inventing that new supercomputer across a new internet that was a new global network of 65,536 tightly coupled processors. I was in the news for experimentally discovering that new supercomputer in Los Alamos, New Mexico, United States, and for experimentally discovering that new supercomputer at 8:15 in the morning of Tuesday, the 4th of July, 1989, the U.S. Independence Day. I was in the news for theoretically and experimentally discovering that parallel processing is an entirely new way of supercomputing across thousands or millions or billions of commodity off-the-shelf processors that were identical and that were equal distances apart and that encircled a globe in 16-dimensional hyperspace and encircled it in the manner the internet encircled the earth in three-dimensional space. At first, my experimental discovery of the massively parallel processing supercomputer was ridiculed, mocked, and rejected. Everybody in the supercomputer community said I had made an embarrassing mistake. But every supercomputer scientist was embarrassingly mistaken. I was in the news because I invented how to synchronously communicate and how to simultaneously compute and how to communicate and compute together and how to do both as one seamless cohesive unit. That cohesive unit was my new supercomputer de facto. That cohesive unit was defined around a 16-dimensional hyperboard that is a new internet by definition. That cohesive unit was a supercomputing machinery that I use to send and receive emails to and from 65,536 or 2 to power 16 16-bit long email addresses. It was not enough that I knew the Philip Emeagwali internet. I knew that internet back in 1974. I knew that new internet as a new supercomputer. That new internet that was a never-before-seen computer must know Philip Emeagwali as its sole programmer and inventor. I invented a new internet that is a new global network of 64 binary thousand commodity off-the-shelf processors. And I invented how to program that new internet to solve the toughest problems arising in extreme-scale computational physics, such as the excruciatingly detailed general circulation modeling, to foresee otherwise unforeseeable global warming. That new internet was a small copy of a never-before-understood internet that had only 65,536 processors tightly encircling a globe, instead of billions of computers loosely encircling the globe that is planet Earth. I visualized each of my 2 to power 16 commodity processors as identical and as equal distances apart and as encircling a globe in a 16-dimensional hyperspace. And I visualized my ensemble of processors as evenly distributed across the hypersurface of a hypersphere in a 16-dimensional universe. I visualized my ensemble of processors as outlining a new internet that I visualized in my 16-dimensional universe. My new internet married my 64 binary thousand processors and married them together and married them as one seamless cohesive supercomputer that had one processor at the crossroad of my 16 email pathways. Those 16 pathways were mutually orthogonal in the 16th dimensional hyperspace. That is, they were perpendicular in the 16 directions of an imaginary 16-dimensional universe. I invented how to speed up computations across that new internet and how to speed it up from 180 years or 65,536 days within only one processor to just one day across that new internet. That's a new global network of 65,536 processors. I invented my new massively parallel processing supercomputer, and I invented it by visualizing my email messages as firing like bullets out of my eyes and as emails coming from computers within a new internet in a 16-dimensional hyperspace. I'm Philip Emeagwali. I'm the subject of school reports because I invented a new supercomputer that was the precursor to the modern supercomputer. I invented a new supercomputer that is a small copy of a new internet. The new internet that I invented is defined and outlined by an ensemble of 65,536 commodity off-the-shelf processors that are identical and that are equal distances apart. That new internet is complex, abstract, and a mystery. The 65,536 processors of my new internet were married together by 1,048,576 bidirectional email wires and married together as a new supercomputer that computed cohesively and did so as one new integrated supercomputer and communicated seamlessly as one new internet. I began supercomputing at age 19 on June 20, 1974 in Corvallis, Oregon, United States. I was the lone wolf and the only full-time programmer of the fastest supercomputer of the 1980s. Today, the fastest supercomputer costs the budget of a small nation. The fastest supercomputer is programmed by thousands of supercomputer scientists. The fastest supercomputer occupies the space of a soccer field. The holy grail of the fastest possible supercomputer is to marry together all the processors in the world and marry them to all the computers in the world and marry them to all the supercomputers in the world and marry processors and computers and supercomputers together and as a never before seen internet that will become a never before seen planetary sized supercomputer that will turn our science fiction to our descendants' non-fiction. I'm Philip Emeagwali. I discovered the supercomputer paradigm in which the boundary between the computer and the internet is blurred. That invention of the parallel processing supercomputer made the news headlines because it had a richness of consequences across science and society. When I began supercomputing on June 20, 1974, I envisioned a planet-sized global network of computers that was the precursor to the internet of today. In subsequent years, I invented a new internet that I called a hyperbole that was described in the book titled History of the Internet. I, Philip Emeagwali, experimentally discovered that my ensemble of processors defined and outlined a new internet that I visualized as my small copy or blueprint or prototype of the internet. Prior to my invention of the massively parallel processing supercomputer that I invented on the 4th of July 1989, each processor within my ensemble of 64 binary thousand processors was like a dim light in a sea of darkness. On the 4th of July 1989, I experimentally discovered that when 64 binary thousand processors are communicating together and are computing together as one seamless cohesive supercomputer, then my 65,536 processors became as bright as the sun. I was in the news headlines because I brought a new face, a new voice, and a new vision to the story of the development of the modern supercomputer that is not a computer per se, but that is a new internet de facto. The lone wolf inventor of a new internet must invent every node of his new internet. A new internet could only be invented by a cross-disciplinary inventor that commanded a broad overview of the frontiers of mathematics, of the frontiers of physics, and of the frontiers of computer science. That inventor of a new internet must have the intellectual maturity needed to bring together discoveries and inventions from disparate fields, such as modern calculus, extreme scale algebra, and massively parallel processing. That inventor of a new internet must bring together highly specialized knowledge that were previously siloed. I invented a second new internet that I called a cosmic ball. In the mid-1970s, my new internet remained science fiction. But on the 4th of July 1989, I constructively reduced that hyperbole science fiction to non-fiction, and I did so when I became the first person to experimentally discover that an ensemble of the slowest 65,536 processors in the world can be harnessed to compute faster than the fastest supercomputer in the world and compute faster while solving the toughest problems arising in extreme scale computational physics. I was in the news onward of the 4th of July 1989 because I experimentally discovered how to reduce the performance abyss between the sequential or the vector processing supercomputer and the massively parallel processing supercomputer I did not experimentally discover the technology of the massively parallel processing supercomputer and invented that technology by inventing how to tweak the sequential processing codes that arose in extreme scale computational mathematics. Nor did I constructively reduce to practice or experimentally invent the new tech supercomputer, and did so by inventing how to vectorize the vector processing codes that arose in extreme scale computational physics. I invented the parallel processing supercomputer from first principles and invented that supercomputer from the laws of classical physics and invented that supercomputer from the partial differential equations of modern calculus that encoded those laws and invented that supercomputer from the partial difference equations of extreme scale algebra that approximated those partial differential equations. In the early 1980s, I invented 9 partial differential equations of modern calculus that fit the second law of motion of physics, rather than invent a law of motion of physics that fit the partial differential equations on the mathematician's blackboard and in the calculus textbook. Mathematics is not a science in its own right. The new calculus that I invented, namely the 9 system of partial differential equations called Philip Emeagwali's equations, is the middle science that mediates between the mind of man and the motion of objects. It is that intermediary position of my new calculus that prompted the debate on whether my new mathematics is discovered or invented and patentable. I see the 9 Philip Emeagwali's equations as inventions that were abstracted from the discovery of the second law of motion of physics that occurred 330 years ago. The physical law that I encoded into Philip Emeagwali's equations existed 13.82 billion years ago when the universe was born from the Big Bang explosion. But the mathematical terms that codified those laws could have been known 13.82 billion years ago, but were not known then. The 9 new partial differential equations that I invented were beings of reason, but what they simulated were real beings. The reason I make this distinction between beings of reason and real beings is because I am often asked, did you discover or invent the Philip Emeagwali's equations? My answer is that I discovered the Philip Emeagwali's equations. If my partial differential equations existed in textbooks of modern calculus and that I invented the Philip Emeagwali's equations, if my partial differential equations did not previously exist in calculus textbooks. For instance, we discovered Mount Kilimanjaro because it pre-existed, but we invented the massively parallel processing supercomputer on the 4th of July 1989 because it did not pre-exist. In computational physics, extreme scale algebra is the recurring decimal and the elephant in the room. Algebra that arose from discretizing the partial differential equation is the way the supercomputer experienced calculus. Those experimental discoveries of how to massively parallel process across a new internet, that is a new global network of processors, enabled me to forge my path to the farthest frontier of supercomputing, that is the modern supercomputer. What made the news headlines in 1989 was that I invented the technology of the massively parallel processing supercomputer, and that I constructively reduced that technology to practice. And I did so on the 4th of July 1989. And I did so when supercomputer textbooks considered parallel computing, many things at once, to be impossible. And I did so in 1989 when all the 25,000 vector processing supercomputer scientists in the world considered it to be impossible to parallel process the most extreme scale problems arising in computational physics, such as general circulation modeling, to foresee otherwise unforeseeable climate changes. The June 14, 1976 issue of the Computer World magazine reported on a special session on parallel processing that was held at the National Computer Conference in New York City. The Computer World magazine reported that a panelist of supercomputer experts at the 1976 National Computer Conference were of the opinion that, I quote, "Those machines often turn out to be large and clumsy, and several of the large parallel processor designs since then have failed. Now we are moving into the modern era." End of quote. When I began supercomputing in 1974, massively parallel processing supercomputer coding was like rubbing rocks until they caught fire. Sometimes it is difficult to translate thoughts from one medium to another. The article is written to be read on a page, but the algorithm is invented to be coded on a processor. For the 16 years onward of June 20, 1974, every supercomputer scientist seemed to be writing articles while I was coding supercomputers day and night, and trying to explain my abstract supercomputer algorithms to the layperson or to the vector processing supercomputer scientist is like trying to rub rocks until they catch fire. I began supercomputing 18 months after the last man walked on the moon. On June 20, 1974, the day I began sequential processing supercomputing, it was easier to travel to the moon than to travel to the frontier of the massively parallel processing supercomputer that is the precursor to the modern supercomputer. In the 1970s and 80s, to parallel process across a new internet that was a new global network of 64 binary thousand commodity off-the-shelf processors was like walking alone through a dark rainforest, and doing so alone with only a dim lamp. My quest for the massively parallel processing supercomputer was my attempt to discover that the impossible to compute is in fact possible to compute. Parallel processing is the technique of fastest supercomputing that is fastest by computing many things at once or in parallel instead of computing only one thing at a time or in sequence. To the supercomputer scientists of 1989 and earlier, to invent the parallel processing supercomputer was to experimentally discover that massively parallel processing the toughest problems arising in extreme scale computational physics is not a waste of time. I was in the news in 1989 because I figured out how to save time and how to do so by reducing 65,536 days or 108 years of time to solution on one processor that is not a member of an ensemble of processors, and reducing that time to solution to only 1 day of time to solution across an ensemble of 65,536 tightly coupled processors that were the building blocks of a new internet that was a new supercomputer and a new computer. My experimental discovery was recognized in the June 20, 1990 issue of the Wall Street Journal. The Wall Street Journal reported that my experimental discovery of the massively parallel processing supercomputer will change the way we look at the supercomputer. In the old way, we thought about a conventional supercomputer as powered by one strong ox. That strong ox was my metaphor for one powerful processor. In my new way, I thought about a modern supercomputer as powered by 65,536 chickens. Those chickens were my metaphors for my 65,536 weak processors. I theorized that the grand challenge problems of our children's children will be solved by 1 billion grasshoppers. Each grasshopper was a metaphor for a computer on the internet of the future. 11 years after my experimental discovery of how to solve a grand challenge problem and how to solve it across a new internet that is also a new supercomputer and a new computer, that invention of parallel processing was reconfirmed by then President Bill Clinton, who acknowledged my invention in his speech of August 26, 2000. That speech of President Bill Clinton was delivered to the Nigerian parliament. I discovered 635 how to reduce 180 years of time to solution to 1 day and do so on a processor. And how to reduce that time to solution to just 1 day of time to solution across a new internet that is across a new supercomputer that is a new internet and that is defined as a new global network of 65,536 processors. I visualize my 16 times 2 to the power 16 email wires as pieces of firewood that connected my 2 to the power 16 processors that each contained kerosene. My scientific quest was to experimentally discover the new knowledge or the intellectual spark that will set my new internet on fire. As the lone wolf massively parallel processing supercomputer scientist of the 1980s, it was imperative that I know how my ensemble of 64 binary thousand processors were married together by my ensemble of 1 binary million email wires and married together as one seamless, cohesive supercomputer that is not a computer per se, but that is a new internet de facto. And that I know that new global network both forward and backward. That new knowledge was not known to any of the 25,000 vector processing supercomputer scientists of the 1980s. That new knowledge was the reason I could set my new supercomputer on fire. For me, Philip Emeagwali, 1989 was the year of fire. The year the massively parallel processing supercomputer became the fire the supercomputer scientists can't put out. The 65,536 simultaneously sent and synchronously received email messages were like bullets out of my eyes. Searching for the parallel processed solution to the toughest problem in calculus was like searching for a black goat at night. My journey to the farthest frontier of technological knowledge and my quest for the fastest supercomputer that is a new internet was a mathematical journey from fiction to fact to forecast. A theory is an idea that's not positively true. Prior to my experimental discovery of the 4th of July 1989, the mechanism by which 64 binary thousand computational physics codes were synchronously emailed to as many processors remained unknown and remained a theory that was not positively true. My experimental discovery of the 4th of July 1989 put to rest the saying that parallel processing is a beautiful theory that lacked experimental confirmation. Prior to my 1989 experimental discovery, parallel processing was widely caricatured and rejected as a huge waste of everybody's time. But in the 1970s, back in the 1970s and 80s, parallel processing was ridiculed as a beautiful theory that lacks experimental confirmation. And my quest for the fastest massively parallel processed computation that could be executed across 2 raised to power 16 processors was like searching for a black box in a dark 16-dimensional universe. Looking back from June 20, 1974 in Corvallis, Oregon, United States, my lone search for how parallel processing makes computers faster and for how an ensemble of 64 binary thousand processors makes supercomputers fastest was like going into the Sambisa forest of northern Nigeria alone and going there to search for the elusive Chibok girls that were held hostage by Boko Haram fighters. Parallel processing was the holy grail and the cheapest girls of supercomputing. Searching for the fastest parallel processing supercomputer was like walking at night and along an uncharted road in the Sambisa forest of northern Nigeria, and doing so armed against Boko Haram fighters with only a small lantern. My quest was for new knowledge, new algebra, new calculus, and new computational physics. My quest was also for a new computer science that could only arise from a new supercomputer that is not a computer per se, but that is a new internet de facto. My contribution to the development of the computer is this. I experimentally discovered that the impossible to compute is in fact possible to compute. On June 20, 1974, and at age 19, I was like a mouse crawling inside the supercomputer that was at 1800 Southwest Campus Way, Corvallis, Oregon, United States. Over the next decade and a half, I grew into the 34-year-old lion that was protecting the world's fastest supercomputer that I discovered to be a new internet that is a new global network of 65,536 tightly coupled processors. Who is the father of the internet? The internet has many fathers and mothers, as well as many uncles and aunts. However, I, Philip Emeagwali, is the only father of the internet that invented a new internet. I visualize my fastest calculations across my new internet before I experimentally discovered the fastest calculations across my new global network of 64 binary thousand commodity processors, or across as many tiny identical computers. I visualized my new internet in a fictional 16-dimensional universe, but I experimentally discovered my new supercomputer in our factual 3-dimensional universe. Fast computation defines the computer. Recording a never-before recorded speed in computation redefines the supercomputer and redefines the boundary of human knowledge. The fastest computation is the most objective and the most measurable contribution to the development of the computer. The supercomputer speed up of from 1 day to 180 years that I experimentally discovered on the 4th of July of 1989 and in Los Alamos, New Mexico, United States, made the news headlines because it was a quantum increase in parallel processing supercomputer speed instead of an incremental increase in sequential processing supercomputer speed. That invention of the parallel processing supercomputer was also a paradigm shift in thinking instead of an evolutionary shift in thinking. That invention of the precursor to the modern supercomputer opened our eyes to the richness of consequences arising from parallel processing across millions upon millions of tightly coupled commodity off-the-shelf processors that shared nothing with each other. That invention allowed us to see the modern computer in a different way, namely as parallel processing across processors. As reported in the news media, such as the June 20, 1990 issue of the Wall Street Journal, my invention of the massively parallel processing supercomputer was not in the new fastest supercomputer. My invention was in discovering a new way of thinking about the new fastest supercomputer and thinking about the supercomputer of tomorrow, not as a computer per se, but as a new global network of tightly coupled processors that shared nothing with each other, and that is a new internet de facto. My experimental discovery of massively parallel processing was processor agnostic or independent of processor technology, and was a blueprint for a never-before-seen internet. The invention of a faster supercomputing is a historical milestone that measures human progress. The reason the invention of how to compute faster and how to do so by changing the way we look at the modern supercomputer is a marker of progress is that it's an invention that makes the impossible to compute possible to compute. The invention of the massively parallel processing supercomputer proves that humanity is progressing in the right direction. I'm Philip Emeagwali at Emeagwali.com. Thank you. Thank you. Thank you.
Insightful and brilliant lecture.
Thank you very much.
Insightful and brilliant lecture.